Hi, I am C. Kannan, Assistant Professor, the Department of Mechanical Engineering of Rover Engineering College, Perambalur. Now, we are going to see the construction, working principle and classification of IC engines. Introduction to IC engine. Topics what we are going to discuss is heat engine, classification of heat engine, applications of IC engine, classification of IC engines, different parts of IC engines, and 2 and 4 strokes engines working principle. Generally, heat engine. Now we are going to see what is heat engine. Heat engine is a type of engine or machine which derives heat energy from the combustion of fuel or any other source and converts energy into mechanical works is termed as heat engine. So, heat engine is a type of engine which converts the energy into mechanical energy. The devices, all the devices used for such purposes are called as heat engines. Heat engine is broadly classified into 2 types. First one is internal combustion engine. Second one is external combustion engine. Internal combustion engine means IC engines. If the combustion of the fuel is ignited inside the engine cylinder, all engines are called as internal combustion engine. The combustion of fuel ignited outside the engine cylinder, then it is used for the purpose of moving the vehicle. It is called as external combustion engine. Internal combustion engine is generally classified into 2 types. First one is reciprocating type, another one is rotary type. All the IC engines, generally we are using reciprocating types of IC engines. Here, the reciprocating type, suppose if the piston is reciprocated inside the engine cylinder, this is called as reciprocating type of engine. The reciprocating type of engine is classified into 2 types. Spark ignition engine, second one is compression ignition engine. Spark ignition engine is nothing but petrol engine. If the spark is used to ignite the fuel, it is called as spark ignition engine. All the petrol engines are called as spark ignition engine. Compression ignition means diesel engine. Why it is all the diesel engines are called as compressed ignition engine? The compressed air only is enough to ignite the fuel, so all the diesel engines are called as compressed ignition engines. The spark ignition engine may be classified into 2 types. If the fuel is used as petrol, it is called as petrol engine. The gas is used as fuel, it is called as gas engine. In CI engines, we are using the diesel as the fuel in compression ignition engine. Petrol engine may be classified into 2-stroke engine, 4-stroke engine. For completing 1 cycle of operation, 2 strokes completed, this is called as 2-stroke engine. For completing 1 cycle of operation, if 4 strokes are completed, these are called as 4-stroke engine. Similarly, in diesel engine, we are also having the classification of 2-stroke and 4-stroke engines. The applications of IC engines, how the cart plays important role in our body. Similarly, IC engines are playing vital role in automobile engines. IC engines have many applications including road vehicles. Examples: scooter, motorcycle, buses, lorries, trucks, etc. Aircraft, motorboats, small machines such as lawn mowers, chainsaws and portable engine generators. All are the applications of IC engines. This is the classification of IC engine. According to the cycle of operation, IC engines are classified into Otto cycle, diesel cycle and dual cycle engines. Second one, according to the arrangement of cylinders, if the cylinders are arranged vertically in an engine, it is called as vertical cylinder engine. The cylinders are arranged in horizontal direction, it is called as horizontal cylinder engine. If the cylinders are placed in V type, it is called as V type engine. If the cylinders are placed opposite direction, it is called as opposite cylinder engine. According to the method of ignition, IC engines are classified into SI engine, that is spark ignition engine. If the spark is used to ignite the air fuel mixer, The engines are called as SI engine, spark ignition engine. All diesel engines are called as CA engine. Thus, compressed air only is enough to ignite the air fuel mixer. All the diesel engines are called as CA engines. So according to the method of ignition, we can classify the IC engine, SI engine and CA engine. According to the method of cooling the cylinder, the cooling is necessary for the IC engines. If the atmospheric air only is used to cool the engine, it is called as air cooling engine. In all two-wheelers, we are using the air cooling system. In heavy vehicles, that is buses, lorries, cars, trucks, we are using water cooling system. If your radiator with the whole setup is used to cool the engine, it is called as water cooled engines. So according to the method of cooling, we can classify the IC engine, air cooled engines and water cooled engines. Generally, petrol engines having single cylinders are having the air cooling system, but diesel engines are having the water cooling system. According to the number of cylinders, engines are classified into, if the engine is having a single cylinder, it is called as single cylinder engine. If the engine is having two cylinder, it is called as two cylinder engine. Suppose if it is having three cylinders, it is called as three cylinder engine. 4 cylinder, 6 cylinder, 8 cylinder, 12 cylinders, we can classify according to the number of cylinders available in the engine cylinder. These are the some classifications of IC engines. Now we are going to see the construction and important parts of IC engines. Cylinder head, piston rings, connecting rod, crankshaft, crank, engine bearings, crankcase, flywheel, governor and valves. These are the important parts of IC engine. Parts common to the petrol engines are spark plug and carburetor. Parts common to diesel engine is fuel injector. Parts common to both diesel and petrol engines are inlet valve, exhaust valve, spark plug or fuel injector, cylinder head, piston rod, crankshaft, wheel, pistons. These are all the important parts of both diesel and petrol engines. Now we are going to see what are all the important roles of various parts. Cylinder is the important part in the engine construction. It contains the whole gas under pressure and guides the piston. It is in direct contact with the products of combustion, and the engine must be cooled with the proper cooling system. A cylinder head is placed above the cylinder. Its main purpose is to seal the working ends of the cylinders and not to permit entry and exit of gases on cover head valve engines. Pistons are plays important role in the engine. It reciprocates inside the engine cylinder. The piston must give gas tight seal to the cylinder, slide freely and be light and also be strong enough. Connecting rod transmits the piston load to the crank. Thus it converts the reciprocating motion of the piston into rotary motion of the crankshaft. The next important part is connecting rod. The transmits the piston load to the crank. Thus it converts the reciprocating motion of the piston into rotary motion of the crankshaft. The crankshaft is attached to the connecting rod in offset areas called throws, where the downward power pulses change into rotating motion. Engine bearings. The crankshaft is supported by bearings. Everywhere there is rotary action in the engine, bearings are used to support the moving parts. Its purpose is to reduce the friction and allow parts to move freely. Crankcase. The oil sump which is used to store the oil is called as crankcase. it is acting like a sump for oil. Flywheel is the energy reservoir which stores the energy required to rotate the shaft during preparatory strokes, and makes crankshaft rotation more uniform, facilitates the starting of the engine and overcoming the start time over governor. The governor is a device for regulating automatically output of a machine by regulating the supply of working fluid. The function of the governor is to control the fluctuation of the engine speed due to the change of load. Valves, each engine cylinder is having two valves. One is called as inlet valve, another one is called as exhaust valve. A valve is a device that regulates, directs or controls the flow of a fluid by opening, closing or partially obstructing the various passages. Spark plug, the main function of the spark plug is to conduct the high potential from the ignition system into the combustion chamber. It provides the proper gap across which spark plug is produced by applying high voltage to ignite the mixture in the ignition chamber. We can easily identify the petrol engines if the spark plug is present. Carburetor is a device which is used for mixing the fuel with the air, maintaining fuel air proportion under all conditions of operation appropriate to the conditions. Fuel atomizer or injector, it is used to inject the fuel into the combustion chamber. It is finally spraying the diesel into the combustion chamber. Stroke is nothing but the linear distance between the top dead center and bottom dead center. Engines are classified into 2-stroke engines and 4-stroke engines. If 2 strokes are completed by 1 cycle of operation, it is called as 2-stroke engines. If 4 strokes are completed during 1 cycle of operation, these are called as 4-stroke cycle engines. Now we are going to see the working principle of 2-stroke engine. 2-stroke engine consists of 2 strokes. One is called as forward stroke or upward stroke. Second one is called as downward stroke. During the first stroke, that is upward stroke, the piston is at the bottom of the cylinder, that is bottom dead center. A pipe at the left side is opened and lets the fuel mixture, which is already compressed a bit, blow from the lower to the upper part of the cylinder. The first gases expels now the exhaust through an injection pipe which is not closed by the piston at this moment. During the second stroke, that is downward stroke, after being carried upward, the piston now covers the pipe on the left side and ejection pipe, because there is no way out anymore. The upper fresh gas mixture and gets compressed now. At the same time, in part below, the fresh gas is taken in by the piston driving upward through the open suction pipe. At the upper dead center, the compressed fuel mixture is ignited by the spark plug. Due to the explosion, the piston is pressed downward while it compresses the fresh gas below at the same time. The process begins again and again in the piston arrives at its lowest point. This is the working principle of 2-stroke cycle engine. Now we are going to see the working principle of 4-stroke cycle engine. The 4 strokes are suction stroke, compression stroke, power stroke and exhaust stroke. Working during the first stroke, that is called as suction stroke. The piston moves from TDC, top dead center, to bottom dead center. During that time, inlet valve opens. The piston sucks the air fuel mixture from the carburetor into the engine cylinder. During the second stroke, that is called as compression stroke, the piston moves towards to the top dead center and compresses the air fuel mixture. The pressure of the mixture rises in the cylinder to a value of about 8 bar. Just before the end of this stroke, the spark plug initiates a spark which ignites the air fuel mixture and the combustion takes place at a constant volume. Both the inlet and the exhaust valves are closed during this stroke. Third stroke, that is called as expansion or working stroke. During this stroke, the mixture is ignited by the spark plug. The hot gases are produced which drive the piston from top dead center to bottom dead center, and thus the work is obtained. The flywheel mounted on the engine shaft stores the energy during this stroke and supplies it to the another 3 remaining strokes. Both the valves remain closed during the start of the stroke, but when the piston just reaches BDC, the exhaust valve opens. fourth stroke, that is called as last stroke. During this stroke, the exhaust gas are leaving the engine cylinder. This process called as scavenging. Thus, the four-stroke engine is working. Thank you for your patience, and we will meet in the next session. Thank you very much.